Okay, this video is an example on how to test the difference between two population proportions. A pilot study in Fairweather County wishes to determine whether mailing reminders to register to vote to all citizens in the county who are eligible will improve voter registration numbers. A random sample of 1,450 potential voters was taken. Then this sample was randomly divided into two groups. Group 1 consisted of 750 people. Reminders were sent in the mail to each member in the group, and out of the 750, 405 registered to vote. For Group 2 consisted of 700 people. No reminders to register were sent to them. The number of potential voters from this group who registered was 355. Let P1 be the proportion of voters who registered in Group 1, and let P2 the proportion of voters who registered in Group 2. Here's the question. Test using a 5% level of significance to see whether the claim that the proportion of potential voters who registered was greater in Group 1. So we need to test, guys, that P1 is greater than P2, and that would be your alternative hypothesis right there. P1 greater than P2, and the null is a statement of equality, so it has to be P1 equals to P2. In order to perform the hypothesis test, we need the number of observations in group 1 and the number of successes, which is 750 for the observations and successes is 405. It's called X1 for successes and observations is 750, N1. For group 2, N2 is 700 and X2 is 355. We're going to run the proportion stats in StatCrunch to sample with summary. So let me walk you through the steps of using StatCrunch. So we go to stat, proportion stats, to sample with summary. And let me bring this down a little so you can see the screen. Okay, number of successes is 405 and number of observation is 750. Number of successes is 355. Number of observation is 700. And we need to test that P1 greater than P2. It means P1 minus P2 is greater than 0. Just look at the alternative hypotheses and select the sign that you see in the alternative hypothesis. Don't change anything there. Just leave the 0 there. P1 minus P2 equal to 0, guys, means P1 equals P2. It's the same thing. So don't touch the 0 right there. Just leave it. And if you want the p-value plot, I can select it, and I'm gonna hit compute, and then I'm gonna bring this down inside the screen so you can see the whole thing. All right. So let me show you here the p-value. You can see the p-value is bigger than alpha. Alpha is 5%. So the test statistic Z is 1.25. And the p-value is 1053. And I'm going to show you the p-value is an area to the right of 1.25. Watch right there. See, this is 1.25 and this is the p-value. When you see too much shading under the curve, means you're going to fail to reject the null hypothesis. So Z is 1.25 and p-value, as you observed, is 0.1053, which is bigger than alpha. Alpha is given 0.05. So what's the decision, guys? Fail to reject HO. And if you fail to reject the null hypothesis and the claim is in the alternative, you cannot support the claim. So you say there is not enough evidence at the 5% level of significance to support the claim that proportion of voters who registered was greater in group 1. That concludes the question.